All right, hey everyone. So first of all, thank you for having me. I'm not from this neck of the woods. I'm usually out in Seattle, where I work at AWS. A little bit about myself, really briefly. I'm a developer advocate at AWS, and essentially what that means is that I'm a dev that works at a company that happens to build tools for other devs, AWS. And my job is to kind of crack the whip internally and make sure we're doing right by all of you and building the tools that you actually want. Get your feedback and help educate all of you. So wherever developers that use AWS are out in the wild, that's where you can likely find me. So that's why you can find me here at this meetup all the way on the other side of the country, and I'm really, really glad to be here. As you probably saw on the topic of today's agenda, we're going to be talking a little bit about reInvent, and we're going to be recapping, hopefully, to the best of my ability, all of the things we have launched at reInvent. This is now, reInvent is this massive event, obviously, and it has now bled out from a launch perspective to even the week or so before that. So I'm going to try my best. It's a really large number of launches. My sort of goal with today's talk is to at least expose you to everything that has been launched at reInvent. So I don't have enough time to dive really deep into everything. There are a few that I have maybe worked more particularly with or that I think are really interesting, but I'm certainly not an expert in every single one of these because they're going to span across the entire gamut. But again, I want you to walk away feeling like none of the launches will have slipped through the cracks. You will have been exposed to it here, and if you want to know more, I'm going to save that questions at the end, or if you want to know more about any of the given services, please let me know, and I'd be happy to forward you along to some of those resources that can help you out. So, in an hour and a half, we'll recap what was about 2.5 weeks of nonstop launches. If it seems overwhelming for all of you on the developer side, well, it's overwhelming for us as well, even on the AWS side. I think the official number we're going with is over 250 entirely new services or features. And so this number is very daunting. We have an internal sort of chat room that every time there's something that newly launched on our What's New blog post, every new launch gets a What's New blog post, and even for the entire week while I was finishing some of the small polishes on some of the launches, I was seeing new blog posts and I was like, I can't believe we're launching this. This is a huge deal, and it's a week before reInvent. So yeah, it can feel overwhelming, but this is hopefully what this should help to ameliorate. We have lots of video links to other parts of the keynote where some of these things were initially launched, as well as videos from some of the deep dives at reInvent. So if you weren't able to make it out to reInvent, like I'd imagine many of you are here, you could actually go find the videos from some of the service teams that launched a given service and see it in action, or see how some of the customers that were using it from maybe like a private beta and their experience along with that. You could take a look at those videos. They're on YouTube. Okay, so this is 250 launches. They're all listed, or the major ones at least, I think, at some point in time. This was before the end of reInvent. But in short, it's a lot of them. They all get their own blog posts, they all get their own content, they all get their own talks. But today you get one talk, and hopefully it's going to cover a little bit of everything. So agenda is a little facetious here because we're kind of covering everything. We have launches across every single sector. I'm going to give a really quick show of hands to try and gauge the audience. If you're really excited about one of these, just raise your hand when I say the category. I'll try and spend a little more time on the ones that it seems like you're all interested in. Compute. Okay, storage. Database analytics. Security and networking. Okay, serverless, dev experience, dev tools. Cool. Infrastructure in general, I know that's kind of broad. All right, cool. And AI and machine learning? All right, cool. Nice. So we'll kick things off with compute. First, we're going to start with one that I think is really, really interesting, even if it doesn't affect all of you. This one is related to AI and machine learning, even though it's in the compute section. We launched at reInvent on December 3rd, general availability of the EC2 Inf1 instances. Inf being the preface to inference. In the machine learning space, you have two aspects. You have the training, by which you take a large amount of data and you process it typically on GPU sort of infrastructure or instances. And then you have the deployment of that, which is a little bit more in line with what we know as standard deployments of applications. Now, when it comes to machine learning, there's a lot of unique constraints and bottlenecks from a computational perspective. One of the biggest ones is the fact that in order to perform inference, which oftentimes may not be a very computationally intensive process, depending on the type of model you're deploying, you oftentimes have to pair what could be a single thread that doesn't need to be very powerful with a large amount of memory, because you need to load that model into memory as an object to basically represent this equation that feeds in the live data and then will give you that resulting inference. This is not really efficient or effective on a lot of traditional servers, and we haven't had the need to do this at scale broadly in the industry. So there haven't been a lot of instances that can do this in a very cost-effective way. AWS a few years back acquired a company. They're a chip maker out of Israel called Annapurna Labs, and so they actually design new processing chips. So when you think of AWS, it's a little bit more than just the software or a dev tool company. We actually designed Inferentia, a chip that more optimally performs these computational workloads all the way down to the silicon level. And what this results in is for folks that are working with inference at scale, they could see up to 3 times performance for the same amount of cost. So again, you can take these workloads that you already know, the same bindings and everything, and just drop them onto an inference, an Inf1 class instance in the EC2 family, and immediately see significant returns. Again, innovating on behalf of customers, this is something, saving money is something everybody wants. And so when we saw the inefficiencies in the existing deployments, this was a clear yes for us to pursue. Next we have the AWS Graviton 2 processor, again, another product out of Annapurna Labs, our internal chip makers. And so essentially this is a movement away from, or not a movement away, but rather increasing the amount of diversity that customers have when it comes to their compute deployment and their compute options. So in addition to existing x86 architecture with Intel-based chips, we see now we have the Graviton 1 and Graviton 2 processor. These are ARM-based architectures. These are developed in-house. ARM architectures typically found in otherwise AMD processors, but essentially these are going to be finding very specific and valuable price to portion ratios for compute, where you can take existing compute workloads and depending on exactly where your bottlenecks are between threads and cores and memory, you can see up to 7 times greater improvements on Graviton 2, 4 times the number of compute cores, and 5 times faster memory. Again, from a dev experience or a customer perspective, this is innovation that we perform and offer new products for, where you can essentially have the easiest lift and shift possible. You're taking code that you're already deploying on one instance type, and you're now deploying it on another instance type. So a very low lift from a customer perspective, but this can result in extreme cost savings or speed ups, so long as this is a good architecture for your given workload, which again sometimes requires some investigation on your end. Okay, for the Graviton 2 based instances, these are the instances that they exist within. So I mentioned that the chips are the Graviton 1 and the Graviton 2. You can see these in the M, C, and R class instances. M is the only one that is generally available currently. This is going to be built for general purpose compute workloads, application servers, mid-sized data stores, and microservices. This one was the most generally applicable, so this is why we decided to roll that one out first. But we have some more specific and pointed offerings in the compute intensive space for the C class and memory intensive for the R class. So oftentimes if the M class is going to offer you benefit here, once we release the C and R classes, much like how you may have differentiated your workloads on existing instance types, you may see even further benefits by further differentiating that down the line. So the M6G is available with the Graviton processor in preview right now as of December 3rd. Okay, next up we have Amazon Braket. So who is excited about quantum computing? Who's heard about quantum computing? All right, that's the expected sort of response I have. Quantum computing, especially so, blockchain, AI, machine learning, these are often referred to as they're very buzzwordy. They take on infinite meanings depending on who's writing about them. I think quantum computing as a science, obviously, and putting it into application is not there from a consumer perspective just yet. We can't just spin up and start working with quantum computing just yet. There's a bit more of lab work that has to be done to make that possible. However, we do identify at AWS how valuable that is across all sorts of different fronts. And so what we've done is we've looked at the industry and where quantum computing is going. And what we've done is we want you as AWS devs to be able to get a head start on developing applications for quantum computing. So while we do not have a quantum computing service, as no one does, that you can just go off the shelf and start using quantum computing for, we have bindings and libraries and a fully managed service so that you can start developing and writing code and relearning how to architect application, because quantum computing is a fundamental shift, not just in the resulting power of the infrastructure and the code that I'll be running, but also how we need to think about developing, because at its core, you're no longer developing with bits that can assume two forms, 0 or 1. You have qubits that can assume many different states, and this fundamentally changes a lot about how we think about software and architecting applications. Really standout sort of applications here come in the form of security and cryptography. That's oftentimes what you'll probably see in the media around quantum computing and how it can break some of those. But again, if you're interested in quantum computing, you can take a look at Bracket and get started with developing and essentially what is a mock layer and a fully managed sort of layer around what this programming interface will be for quantum computing when the technology is fully there for consumer readiness. Next we have AWS Nitro enclaves. So this is improvements to the virtualization layer. AWS, again, I mentioned, we do everything all the way down to producing our own chips, but something that's maybe a little more commonly known is that obviously we're running those data centers on your behalf. And so as a part of those data centers, between when you have your EC2 instance and the bare metal and the electricity that's plugged into them, we have some software and middleware that's running in between to facilitate you being able to really efficiently spin up and provision your instances and to be able to allocate and do those bin packings as efficiently as possible. We call that the Nitro system, and so with reInvent at December 3rd, on December 3rd we launched Nitro enclaves, which are essentially added levels of security for isolating workloads and being able to facilitate locking down of data between some of these additional these virtualization layers between the instances that all may live on top of the same Nitro hypervisor on a given set of bare metal. Next we have AWS Compute Optimizer. So what this is going to do is it's available in the management tools through the AWS console. The goal here is to look at a given workload that you're running on some set of infrastructure. Think of a class of EC2 instances, for example. There are best practices around the amount of utilization you may want. We recommend it's typically around 80 to 85% utilization. Depends on the workload. That's very general sort of advice. The idea behind that is in an auto-scaling scenario, if you're keeping your utilization all the way up to 90 or 100%, while your instance or your cluster is going to auto-scale up, you may have a lag period where your requests are building up before the new instance is available. So that 80% number enables you to have a little bit of leeway to go up. Essentially what Compute Optimizer is going to do here is it's going to assess the historical data around workloads that you have on a set of instances, and is going to recommend and predict, using machine learning, other instance types or combinations that can more efficiently, hopefully, run your workload. Ideally, again, here, it's still all EC2 under the hood. You don't have to think more or deeper about your workload, but this is sort of just like a flat value add that you can, should it provide an insight that it thinks will reduce your costs, you can try that out. A little picture of what this looks like. So this is inside a Compute Optimizer in the AWS console. So for a given test that I have run on a specific workload, we can see here at the top, this is going to be my current deployment, or the status quo deployment. We see here an instance type M5 2x large, the cost, which is again all on demand here in this scenario, so 384 or 38 cents an hour basically. And so what it's essentially doing is something called power tuning. It's trying to assess where the bottlenecks and where the scaling of both memory and CPU is as a function of time as you run this workload, and see if against other internal benchmarks and training data we have on similar types of workloads with those stressors and bottlenecks, where that can be improved. So we see here that there are other alternatives down here where you can reduce costs using something like an M5X large or a T3X large. Now this is something that customers are already often trying to automate on their own, but it's oftentimes within a given instance class. This makes a lot of sense, right? Like within a given instance class, you understand what that instance class or family is optimized for, and it's clearer to understand, well, if I'm CPU bound, I need to scale up my CPUs, but maybe my memory, I'm not getting the best bang for my buck around that. Now it's easy to sort of like experiment across one dimension and deploy and see, all right, well, let's say M5 2x large work best in the M class family for me for my assessment, but what Cost Optimizer is really ideal for, or Compute Optimizer is really ideal for, is to be able to scale out this experimentation, one, automatically, but two, across a lot of different instance types that it may otherwise be very expensive or very tedious to do on your own. Okay, next up we have Savings Plan. So who has used reserved instance pricing before? And who liked reserved instance pricing? Okay, so this is feedback we've gotten in the past. Obviously, there are scenarios where reserved instance pricing works really well, but ultimately, I think the same thing in the same way that we want to offer elastic and you know, completely on-demand service and value for you where you pay when you're receiving value. We found that reserved instances oftentimes don't always align with your exact workloads. Within a given year, your needs may change so that the reserved instances you pay for are no longer optimal, or sometimes they may even be sitting there. That's something that was very resounding with us, and so what we wanted to do is we wanted to sort of work backwards from the idea of you being able to commit some sort of workload ultimately, rather than a specific instance type, for example, and rather from here we have flexibility within the instance classes and families. So savings plans are what enable you, they're a permutation of what used to be reserved instances, where we start with the workload, we start with what that will look like, and it enables you to ultimately save a lot of money. We find that, again, in a perfect scenario, it may work out to be very similar because you may have perfect utilization all year round in a reserve instance scenario, but this flexibility is very valuable to customers, and ultimately you have the peace of mind that you're not going to be locked in when new advances come out in new instance types, that you're already locked into a reserve instance that came out previously. Okay, next up, who's excited about Kubernetes or EKS? Well, I'll get into EKS and Fargate, but Kubernetes, anyone? Okay. 1, 2, 3. For those that are not super familiar with Kubernetes, it is a container orchestration engine. Containers, again, in a microservice world, the idea is you'll have different containers running different microservices. They communicate with one another. Kubernetes, and there are other services that handle things like service discovery and so on. Kubernetes is the most prominent container orchestrator, to my understanding. But there's a lot of ops work into running Kubernetes, and while containers are really valuable for bringing those microservices to the cloud and making those reproducible and sort of atomic in a way, Kubernetes is still kind of tough at times. And so Fargate, AWS's serverless compute engine, essentially for running either EC2 workloads or containers, now has direct integrations for Amazon EKS to help remove some of the serverful aspects of EKS to make that a little bit easier for you to run those, both in from an ops perspective and make it easier for you, but also to help you save a little bit of money so that you're not worrying about unused like compute capacity in an instance or a cluster for EKS. So again, focus on building your applications. That's what you care the most about. All right, next up, a bunch of smaller container launches, but each of them immensely valuable if you're using any of these services. So who uses or has heard of EC2 Spot before? Okay, so a handful. We recently launched Fargate Spot. So the value proposition behind Spot is broadly that a lot of customers will often buy on demand. They have the elasticity. Maybe they have a very cyclical workload where they need to scale down to zero. So that on-demand aspect is really valuable. But as a part of our own internal capacity planning, we always want to make sure that no matter how much you as customers want to provision capacity, that you're never sitting there waiting or ever going to receive an error where AWS has run out of capacity. As a result, we over-provision so that you don't have to worry about that. And we always have some amount of spare capacity. So even for the peak demand that we expect at any one point in time, we still have more infrastructure to cover more than that. And so what we figured was we could introduce a service called Spot, where we kind of sell this spare capacity or rent it out through these services, but at a reduced cost. So if you are used to using on-demand instances for EC2, for example, you could rent spare capacity, where the only downside of using a Spot instance is that there is a risk of termination. Now what that means is that there's two things. You will get a CloudWatch alarm, so a programmatic notification that instance will be terminated in the next 10 to 15 minutes. And additionally, you will have within the actual the operating system on the guest operating system, you will be notified. Now, if you can build resilient applications that are used to failing gracefully, Spot becomes really, really valuable, and you can basically save up to 70% on any of your EC2 instances. EC2 customers have been using this for a while. There's a lot of really good ways to handle auto-scaling and running cyclical workloads or non-mission critical workloads on that don't need to be persistent. We've recently brought it to AWS Fargate. So you can use that with Fargate with completely like serverless workloads with up to 70% off. So very valuable. Next, we have Amazon ECS capacity providers. This is sort of a signaling of a larger trend that we at AWS believe in the industry, which is, if hasn't been apparent with a lot of the launches we've seen so far, I think it will be when I say it in this way. We want customers to think less about fitting applications into these arbitrary delineations of deployment infrastructure and worry more about your workload and understanding the actual scaling mechanics of the workload independent of a given instance or a container or some like Kubernetes, right? We want you to just think about writing your application code, and at the end of the day, you want to see how compute and threads compare to or scale alongside memory utilization and disk space, and where is your application wasting time. We don't want you to worry about bin packing those into instances or into containers. And so ECS capacity providers is this first example of being able to sort of think about your applications in a container-oriented way where you don't think about the underlying infrastructure for the container. You simply pair, like ECS capacity providers is much more about pairing the fundamental properties of memory and compute directly in the ECS service, Elastic Container Service, to your workload and abstracting away the infrastructure that it runs on under the hood. Those containers run somewhere on some type of instance with some type of processor, but at the end of the day, it's not always critical that every single one of those is running on the exact same exact infrastructure. The most important thing is that they're running optimally for what you care about in the bottlenecks of your system, and that you're not paying for unutilized space. So this is really exciting launch. I know that description sounds a little vague, but this is a precursor to a lot of other things that we have down the line. And by defining workloads as capacity units of memory or of like number of cores for compute or of data storage, like we've done for many services in the past, this is really a precursor again to a lot of exciting stuff to come. But you can start using it today. All right, next up, ECS CLI 2.0. This is a complete developer experience overhaul of the Elastic Container Service CLI. So we've called it 2.0. Essentially, instead of having to leverage some of the standard CLI aspects, we've taken an approach where we look at the workflows that you will have as a developer and have what are essentially, if you could imagine like wizards in the console, we've tried to take that experience, and instead of trying to ask you to bring a bunch of pre-formatted perfect config files to the table, you can actually walk through the ECS CLI wizard, and it will help to auto-generate a lot of these things. They'll ask you questions that have multiple choice where you can use the arrow keys to scroll all from within your terminal. So again, a lot of people like the GUI, but they want to do it programmatically. They don't want to leave their terminal. ECS CLI 2.0 is going to be really slick for those users. Next up, we have ECS cluster auto-scaling. Again, Elastic Container Service, you may have a cluster, you may have multiple containers all working together on a given task. Let's say you have that ECS cluster as a target for a given set of inputs, so that you basically now have, with ECS cluster auto-scaling, the ability so that when that cluster is now hit with more requests to perform workloads, one example would be like, let's say you have an ECS cluster that handles video processing, right? And then you have a large number of videos that all come in all at one time for some reason, and you need them processed. Rather than throwing all of the extras into a queue that filled up the maximum size of your cluster, with auto-scaling you can have that scale up on demand, but also not just scaling up, but scaling back down to as small of a cluster as possible when the demand is not there, so that you're not paying for unused capacity. Okay, cool. EC2 Image Builder. I'm going to be going a little bit quicker through some of these other ones. They're a little bit more straightforward, even though some of them may be unclear without developer experience. But I'm on slide 15 of 120. So those were some of the longer ones in the beginning, but I apologize, I'm going to have to go kind of quickly. So yeah, EC2 Image Builder, again, another launch in the compute segment, makes it easier for you to be able to manage your EC2 images, your AMIs. More baked in, more adequate security baked in out of the box as best practices, so that you don't have to write those from scratch. And ultimately, it reduces the time that you can go from trying to build your own custom image, because we're baking some of those best practices in through the wizard. Next up, License Manager. This is specifically for Windows and SQL Server, or Windows Server and SQL Server. So due to recent changes in how Microsoft is handling licenses or complications in how that is working on non-Microsoft or non-Azure given infrastructure, we have simplified the experience for you to be able to bring licenses, importing them into License Manager, and streamlining the process by which you are managing the delegation of those licenses amongst your underlying infrastructure. Again, this is something that is just undifferentiated heavy lifting, as we like to say. You don't get value from having to build your own system to manage these licenses and to efficiently allocate them, or to feel blocked when you can't spin up an instance because you don't have an on-hand license to provision to it. Windows Bring Your Own License for License Manager makes that much easier. Next up as well, we have further extending some of the Windows Server launches, end of support migration program. So everything from best practices and tutorials and documentation, but also some automated analytics features for assessing your workload and version breaking changes when you're migrating from an older version to a newer version of Windows Server. Again, at the end of the day, you want to keep your applications running and do that and perform that migration in as quick of an amount of time as possible without having to hopefully change your application too much. And so migration program is essentially a suite of offerings, from content to passive sort of assessment tools to active assessment tools, to be able to make this migration as simple as possible and streamlined as possible so you could get back to working on other parts of your applications. Storage. Okay, so on November 20th, so this was a little over a week or 2 weeks before reInvent, we actually launched a slew of storage-oriented capabilities. So we have 15 listed here. In S3, we have replication time control. In EBS, we have fast snapshot restore, FSX for Windows File Server, multi-AZ deployment, data deduping, user quotas. I'm not going to read every one of those. AWS Storage Gateway, we have high availability for VMware, performance increases for tape and file gateway. AWS Data Sync, price reduction, 68%, so pretty drastic. Scheduling of tasks so that you don't have to instantiate them immediately when you're invoking them or calling those data syncing tasks. And availability in 5 additional regions. I know here in the United States that is not always something that is too exciting to us because we oftentimes get a lot of those services first. But rolling these out to other regions is not always an easy task. So 5 new regions at one time is a pretty big deal. And then on the Amazon EFS side, it's now available in all regions as well. So again, extending the benefit of having this service available globally. Next up, this one's actually really interesting. So Amazon S3 access points. So who that works with data sets that are stored in S3 has issues or like trouble with trying to manage multiple tiers of access to those data sets? That's a pretty nuanced example, so I don't know how many people would fit that description. But I do. I work a lot with AI and machine learning, and I find that a lot of the customers that I've worked with have not in the past had a really great answer for this. So what customers have done in the past when they want to manage different versions of a data set or nuanced permissions to a data set is oftentimes they'll actually duplicate that data set into multiple folders or multiple S3 buckets where they've now granted a different subset of people different access permissions for each one of those subsets of the data. This is clearly not efficient in any way, shape, or form if that wasn't obvious from the way I described it. But essentially S3 access points are an improved interface by which you can actually basically delegate different access patterns to different parts of the data in a given S3 bucket or in a given VPC, for example. So you can further customize that access without needing to do inefficient tasks like duplicating your data and then ultimately paying for that data, but also then having to manage the complexity of versioning data sets that all basically exist in parallel and are the same thing, that exist for the sole purpose of being able to make sure that people can all access it differently. So S3 access points are really exciting for that. Next up on storage, EBS Direct APIs for snapshots. This again is a simple set of APIs. It enables you to directly interface with EBS snapshot data. If you want to perform your own sort of custom backups or to be able to perform this in cheaper or quicker ways, this is now possible. Ultimately, one of the things that jumps out the most here is the fact that you can make more incremental changes to EBS snapshots. So rather than making entire EBS snapshots at entire points in time that are essentially completely isolated from one another, one of the benefits of these direct APIs is that you can now essentially perform the diffs from each of these snapshots. So your original snapshot may be the full state of an EBS snapshot, and then maybe I change only a few small parts of my data. Rather than having to basically perform a copy and paste for that new snapshot, all I need to do is, all that new snapshot data needs to be is the pointer to the original snapshot and some diffs from there. What that means is that you can back things up significantly faster. Think about like a git diff versus completely cloning your repo over and over again. So you can do this faster and save a lot of money because your diffs are now significantly smaller. If you want to learn more about that one, I actually have the link, the talk name here. I'm also gonna, I don't know if I can give out this slide deck, but if any of these things are interesting to you, please talk to me after the talk, and I will get you the actual talk that we gave at reInvent that dives deep on that concept. So yeah, cool. That was storage. Now two other things, two concepts that are related to data and storage, databases and analytics. Next up, who uses Cassandra? Anyone, out of curiosity? One? Okay, yeah, another. So at reInvent, we launched a managed Apache Cassandra service. The thing that's most exciting to me here is that this is completely serverless. So I know not many people have used Cassandra. Has anyone used DynamoDB before? A good number. Sorry, I know I keep making you all raise your hands. But one of my favorite parts about Dynamo is that there are no instances to provision. I just click create table, I give it a name, and I go. I can start inserting items into it immediately, and I can start integrating new secondary indexes, sort keys, and so on and so forth. I really like that developer experience, and I know that a lot of developers have after I speak to them as well. And so I'm really glad we can bring that to the Apache Cassandra service that we're launching. Again, fully managed, so you get all the benefits of that: security, patching, updates to the service in an automated fashion. And so if you bring your Apache Cassandra bindings and code that you're using with those existing toolkits, those will work out of the box with the managed Apache Cassandra service. So again, no need to reinvent your code to work, no pun intended, with the managed Apache Cassandra service. Okay, Amazon Aurora machine learning integration. So this one is not always intuitive at first glance. We launched this a week prior to reInvent. So when we think about machine learning, one of the biggest precursors to that is data, and I don't mean to be broad when I just say the word data, but there's just a lot of parts around it. How we're storing it, how we're getting access to it for the folks that need to perform machine learning or analysis on it. But then also how it's going through the lifecycle management of it. And so oftentimes we're finding that whether your data is in a data lake or it's in a database, the next immediate step from pulling that data in from that data lake is ingestion into your application of some way, shape, or form. And so typically, there are a lot of customers that outside of serving requests for other more mature microservice sort of architectures, they still want to work with machine learning, but they may not have either the developer skill in the machine learning space or the knowledge of the services like SageMaker or the managed APIs like Comprehend to be able to leverage this. But we do know that the next step after pulling the data into an application is to perform that machine learning inference on it. So what we did with the machine learning integration for Aurora is basically say, hey, you're performing a query on your Aurora database, you're pulling in a bunch of text, let's say it's user reviews for the items, for example. Well, a really common use case there is to be able to perform sentiment analysis on that text. Are the reviews positive, negative, mixed, neutral? So basically what we did is we made a bunch of bindings that make it really easy for you to kind of check a bunch of boxes and not need to always understand in depth how to use these underlying services like SageMaker or Comprehend. And for a lot of really common workflows, we've pushed the machine learning directly onto the database where you can opt in and basically have on query time analytics included as extra features along with those columns. So in Comprehend, like I mentioned here, which is in preview, if you're querying, let's say, example text fields from your database from user review data, you could right along with the results of that query, have the sentiment included in with that. So whichever part of your application stack is creating your database, now it's super powered and basically gets additional data along with that without you having to write additional application code to sort of marry the two together and merge them. Again, integrating this machine learning with Aurora, you're getting all the benefits of it being a managed service with all the security that comes along with it, encryption in flight on the sentiment that's coming along and being married and merged to your data set and the results of that. And again, because we understand the hardware really in depth that this is all running on, and it's fully managed from the query layer down on our end, we can make this really low latency and very quick, where even if you did implement this on your own, it's not always guaranteed that it would even be the same performance. Okay, next up, Amazon RDS proxy. Who uses RDS? Okay, good number of you. Yeah. So Amazon RDS, Relational Database Service. This is the broad umbrella service for all of the underlying relational database engines. So we have Aurora, Aurora MySQL, Aurora Postgres, Oracle, SQL Server, so on. There's a bunch of them. I think there's like 6 or 7 or 8 of them. But basically, one of the things that people that work with databases have to toil over all of the time is not just how to get my data into my database and to model it efficiently and have good sort keys and stuff in a non-relational database, but to also manage the access patterns around who is accessing it. Do I have a caching layer in front of it? How do I manage a connection pool? How long do I keep those connections alive? All of these things directly dictate the size of your cluster, when you should scale up, when you should scale down, how you should break out the scaling between reads and writes. It's an entire art form. But ultimately, this starts to fall under the territory of undifferentiated heavy lifting. This is something that we think about all the time. What are things that are not providing unique value to you, but we can build a service around so that you can focus and spend that valuable developer time on other things. And so that whole world of managing connection pooling and database failover, RDS proxy is a basic HTTPS proxy in front of your database where your applications, instead of querying the database directly or your own personally managed proxy where you have to write the policies for that connection pooling, you simply connect to a persistent endpoint, an HTTPS endpoint. You perform all of your native SQL queries, for example, or Postgres queries, or you can make API calls directly to it depending on what you want to do. And RDS data proxy handles all of the connection pooling to the underlying database. So in a world where your database actually fails over, you don't have to worry about the new addresses and the new locations of your database, because the RDS data proxy automatically does service discovery for the location of that new version of that instance if it failed over for some reason, or of your cluster. So when you build the data proxy, you get all of the fully managed benefits of that. And you get that persistence so that when anything is happening or scaling under the hood, you don't have to have built your own really efficient, really performant custom code that you're managing as the intermediary layer. That's in public beta, and that launched on December 3rd at AppView. Okay, this was an exciting one as well. So Amazon Elasticsearch Service is a managed Elasticsearch service in the cloud. Again, this is typically used for efficient storage and processing, analytics, visualization of log data oftentimes, but it can be used for a lot of different things. It's very dynamic. One of the things that becomes very difficult is when you start getting a certain size cluster or a certain amount of data inside of your Elasticsearch cluster, you may notice that some of your queries are taking longer than you'd like them to be. Part of this is part of how Elasticsearch as a tool is built under the hood. But essentially, what we saw consistently across customers is that anyone who really likes any sort of data service that accumulates data is going to reach scale at some immense scale at some point. And so this whole idea of like a service not being as performant as we want it to be at extreme scale is not something we wanted to sort of rest on the laurels with. So we introduced something called Ultra Warm for Amazon Elasticsearch Service. And essentially what this is it's a internally managed layer of lifecycle management for basically realizing when your data is getting cold in an intelligent way and being able to put that data or reallocate that data to another part of your cluster for basically 1/10 of the cost. So in the same way on Amazon S3, we've had this concept of you have the hottest layer, and then you have infrequent access, and then you may have like significantly colder storage with things like Glacier, where you're making a trade-off between the amount of time it takes to access the data when you do want to query it, but then saving a bunch of money on how much it costs to keep that. We found that in Elasticsearch, when you're putting things like logs in there all the time, there are very clear access patterns a lot of the time that we can automate the analytics of, and take those logs based on your access patterns and migrate those into colder storage. So again, a somewhat automated process that enables you to basically save a ton of money, up to 90%, on a lot of common workloads for customers that are using Elasticsearch on this log data that you want to keep around. You want it to be in Elasticsearch. You don't have to pull it back in from S3 for this example, but you don't need it to be available right away. You can wait a second or two or a few seconds for that to be accessed, especially at 90% cost savings. That's a trade-off a lot of customers are extremely willing to make. Next up, Redshift RA3 instances with managed storage. One of the other aspects of databases, and I know Redshift is, some people say it's a database, some say it's not, it's a data warehousing tool. One of the biggest ways, whether it's a compute workload or a storage workload, to help you achieve more data is to further break out the separation of the bottlenecks for your application, whether it be compute, whether it be the storage of data, whether it be reads and writes in database scenarios, whether it be memory. And so with Redshift RA3 instances with managed storage, essentially what this is it enables us to further differentiate the compute and storage layers of your data warehousing solution. So instead of having to exclusively pay for these, again, like I described before, arbitrary sort of chunks of data warehousing layers, like your workloads don't always scale up linearly with memory and compute, and so by separating these, you can more effectively pick and choose to match your workload. Don't pay for unused compute capability, and so at a given desired price point, we found that it can deliver up to 3 times performance. And as far as scaling, again, that's obviously something that people think about in a data warehousing scenario because you have a lot of it there. This is rated to support workloads up to 8 petabytes. So it scales. Next up, we have Aqua, another Redshift-oriented launch. Aqua stands for the Advanced Query Accelerator for Redshift. Essentially, this is a hot, in the same way that we have separated, the compute from the storage within your data warehousing solution. In instances where you're using the Redshift compute engine to query S3, for example, we have this Aqua now represents this hot caching layer between the two that just makes it significantly faster to process the data on S3. So Aqua is basically like think of it like a compute accelerator that's sort of tacked onto S3, where you've given Aqua the instructions from your Redshift compute cluster, and it can exist closer to the S3 storage to perform those operations much faster. Aqua is really exciting, especially if you use S3 a lot for as part of your data warehousing solution. And it's 100% compatible with the current version of Redshift. So very, very exciting. Any of the operations you're performing currently with Redshift will be supported out of the box. Now, with that being said, Aqua is still in private beta. If this is something that's interesting to you, please go into the console and fill in that you're interested. This is not, like a lottery sort of scenario. If you are interested in this and we think that it would be a really good fit for your given workload, we'd love to be able to try and get you out of the gate with this. Obviously, we can't support everybody while we're in private beta mode, but please, that button does do something, and we'd like to get this in the hands that work with you so you can get this value sooner. Next up, we have federated queries for Redshift. This is in public beta, launched at reInvent. The idea here is to be able to, much like the idea of S3 being able to exist as sort of a catch-all from a data storage or a data lake solution, Redshift from a data warehousing side should be able to be a catch-all from being able to query your data and to be able to perform these data warehousing tasks essentially, regardless of the storage layer that they exist under the hood. So in Redshift with federated queries, essentially we can perform queries now across multiple different forms of data storage. So you can do Redshift queries across like RDS Postgres, Aurora Postgres, S3 Data Lake, because in reality, at the end of the day, depending on both the type of data that you have, but also how it's being accessed to other parts of your organization, we don't want you to have to, again, duplicate your data. Like, if it exists in a database, we don't want you to have to duplicate it and put it also in S3 for the sole purpose of it being compatible with Redshift. Instead, we want you to give us the feedback that you want that federated query, and that's how it results in features like this, where customers tell us, hey, this is where our data is, why can't we use it with Redshift yet, can we get an improvement there, and then we launch features like the federated queries for Redshift. Next, data lake export, so sort of like in reverse, I guess, in a certain way of federated queries. So rather than being able to have multiple sources for the source of ingestion, being able to export your the results of your exporting the results of your warehousing operations essentially, or analytics on your data, whether you're using EMR, whether you're using Athena. you can output all of these and manage all of these sort of these processing threads sort of simultaneously through Redshift. And then you can put those to S3. You can have those operated on with Glue for ETL if you want to perform some sort of pre or post processing on them. So really valuable, very valuable if you're doing a lot of warehousing. This was GA at reInvent. Okay, I'm now 30 slides through 120, so we're going to get even faster. I apologize, but I want to make sure that we can get through all of this. Next up, AWS Data Exchange. Really briefly, this essentially becomes a marketplace for providers and subscribers of data. Think of this like a company that may have like a weather balloon that exists out and they want to be able to, similar to a marketplace solution, you can spin up an application that someone else has built and you can pay for that or provide that. This is a similar sort of aspect but for data. This is very common for examples where you have, again, recurring data that's recorded continuously and it makes sense for your organization to pay for someone else to manage that acquisition of the data rather than you to do it yourself. A very common sort of understanding. This was announced on November 13th, so almost a month before reInvent. Next up, security and networking. This is one I know I saw a lot of hands for before. So first we have CloudTrail Insights. Essentially this is automating the process by which you can assess sort of like your CloudTrail logs. CloudTrail, again, going to be a ledger, a history of all the API activity for the given resources on an account. Now, Insights is an automated way to be able to introspect all those different behaviors and some of the most interesting things that we want to know, like anomalies, or if a user that's been really inactive finally made another action, we can develop CloudTrail Insights enables you to more quickly and easily be able to perform these analytics and ultimately be a little more proactive when weird CloudTrail access is happening or account access. This is oftentimes nefarious or people are maybe getting access to resources they shouldn't be. CloudTrail Insights can help you then set alarms around these anomalies to be able to get on top of these things before you have significant economic or financial damage to let's say, your company. In a similar extension of this, we have an entire managed service around this exact scenario. It's called Amazon Detective. The idea is to, around security flaws or around incidents essentially within your AWS account, it can break down the sort of the layer of responsibilities or changes in an account. So if the public-facing sort of scenario is that a bunch of your instances went down. If you perform an introspection into how that happened, you're going to first look at the person that performed the action, or you're going to look for the action that tore the instances down. You're going to look at the person who executed the command. You're going to look at the IAM credentials that they had. You're going to look at whether those changed. Detective is essentially a managed service to play the role of detective and try and help you distill the core and the fundamental actions, and as a result, the insecurities that you may have had in your account that led to these, so that you can not just lock down that existing problematic account, but also actually fix the core problems that caused this to happen in the first place. So you can have peace of mind that this exact flaw is not going to be implemented against you again. Next up, AWS IAM Access Analyzer. This one's really, really cool. Essentially what this does is it builds out an entire a formal logic process for all of your IAM roles and the users and the services that they've been assigned to. When I say a formal logic, I mean that in the actual theoretical, like mathematical sense. What this does is it can say definitively when you run the IAM Access Analyzer on all of the policies in your account, you can find out exactly what roles would have permission under certain scenarios, and you can define parameters in IAM Access Analyzer to say, if this scenario is possible, I need to be alerted. Where a person of a certain role is given, could be given access to something. It's not even a matter of do they have access. IAM Access Analyzer can actually analyze the sequential sort of flow of these permissions to be able to determine preemptively if there is a flaw in the way that you have designated your IAM access privileges. This is something where an existing user in your account may not have the permissions, but if there is a workflow by which there's an unintended escalation pathway to either giving a service, like a common example for this would be like if someone hijacks your EC2 instance and they use that EC2 instance to also spin up a bunch of other EC2 instances to mine Bitcoin on your organization's account. With IAM Access Analyzer, you could preemptively understand that because it would surface that EC2, one single instance, if SSH'd into, should not have permission to spin up other EC2 instances, for example, or only spin up EC2 instances in a given auto-scaling group. So it's really, really cool. This is something that otherwise is a very manual and tedious process. Single sign-on. This is something that is, a big quality of life feature, but more particularly Azure AD support for it. So this was announced a week before reInvent. So you can continue to use existing identities that your organization may have in Azure AD, and you can now integrate those directly with AWS SSO. So if you're using Azure AD, this is something that is probably something that makes you very excited. AWS Transit Gateway, this was an existing service that enables you to scale your connectivity across thousands of Amazon VPCs, accounts, and on-premises networks. But what was newer at reInvent, which we launched as generally available, is Transit Gateway inter-region peering. This enables you to truly take transit gateways from multiple regions and peer their connections together so they can essentially operate as essentially a single virtual region. Depending on the networking demands for your given workloads, this may be necessary. Oftentimes, we recommend customers build with the region being the atomic end of a given root of your architecture. But there are scenarios in which there's resilient patterns for architecture for how your data lives in databases, for example. But there are scenarios where you may want to get that data from another part of the world, right? And so, using Transit Gateway for inter-region peering, this now allows that. In a way that doesn't make your region's deployment necessarily dependent on other regions directly, which is what we advise against. Next up, Accelerated SitetoSite VPN. It's like a VPN, but it's fast. It just improves your VPN connections. It's not much else to say there. It was generally available at reInvent. Transit Gateway Network Manager, this is again going to be more on the observability and introspection side. So with all of those, with Transit Gateway, you're trying to manage connections, flow of data. With Network Manager, this is simply going to automate the process of having dashboards around this built natively into the AWS console and make it really easy for you to understand not just the aspects of your network, but also here it has some suggestions for how you can actually optimally route. And that's not necessarily always like with machine learning, but rather some more best practices that are simply baked into the wizards and such. Better defaults are oftentimes one of the biggest places of low-hanging fruit for some of these scenarios. Okay, Transit Gateway Multicast. This was also GA at reInvent. It enables you to build and deploy multicast applications in the cloud. I personally have never built multicasting applications before, but I know for those that have, they've been really excited about this. Ultimately, it enables you to also have auto-scaling to scale your multicasting architecture up and down. And one of the biggest issues with multicasting is that people were always having to provision for peak. So again, scaling up is really nice. Knowing that you don't have to worry about having to pay for latent architecture or latent infrastructure is good, but that you also don't have to know necessarily what your peak may be, which I think is one of the best parts, right? Like if your application or your company goes viral overnight, you don't want to suffer from success where your application goes down. Transit Gateway Multicast also has that auto scaling to give you that peace of mind. VPS ingress routing, route inbound and outbound traffic through a third party or AWS service. Don't know really what else to say about this. This was launched at reInvent, basically helping you to extend ingress to your VPC to another third-party service that may not directly be an AWS first-party service. Okay, next up, serverless developer experience. I know I saw a lot of hands for serverless as well. Okay, provision concurrency on Lambda. Who's using Lambda or has used Lambda? Okay, from everyone who didn't raise their hand, who wants to use Lambda or is interested in it? Okay, so between those two groups, it's most of the people in the room. So Lambda is really cool, serverless cloud functions with a ton of other functionality built into them. But ultimately, one of the parts of Lambda that had frustrated many developers is that while it is really, really nice to be able to have an event happen or to invoke a Lambda and have it spin up and run and tear down, was that oftentimes there are scenarios where that spin-up time, as negligible as it may be too much for the round-trip latency for your given workload. And so with Lambda, you can actually set in the console a number of your peak concurrency. Some of the Lambdas will stay warm depending on your access patterns. Some of them will cool off depending on the given traffic at one point in time. And the cool ones being provisioned are where this latency starts to come into play. Now, with provision concurrency, the developers can go in the AWS console and specifically designate a number of a minimum floor of pre-provisioned Lambdas that will remain warm. Now, this doesn't mean that you're paying for them to be running like a server, but you can essentially designate a amount of them to be initialized and hyper-ready, essentially. So it keeps those start times in the milliseconds and ultimately ensures that you have a certain number of Lambdas that will deliver at warm performance within your architecture. So you don't need to do any code changes to be able to implement this. This is just a feature flag inside, and builders can set when they have this provision concurrency, and it adds just a little bit of cost depending on the number that you want to have pre-warmed. And it's configurable through auto-scaling. Next up, HTTP APIs for Amazon API Gateway. API Gateway service that has been around for a very, very, very long time. What we heard from customers was that they love API Gateway. It is essentially feature-packed with all of the aspects that they want, from just basic routing to security and auth and so on and so forth. And it works really well. But there are a lot of scenarios in their architectures where they wish that they could simply have a more streamlined HTTP API gateway where it maybe didn't have security and came at a lower cost. And that's exactly what we launched here with HTTP APIs. So if you're looking for the fully managed sort of frontward-facing sort of API gateway in the way that we all have used API Gateway in the past, then that is still a really good option. But for otherwise traffic routing, for very basic HTTP routing of requests, HTTP APIs are basically a pared-down version of API Gateway without some of those security and other bells and whistles, and ultimately you can save up to 67% by using this one instead of API Gateway in different parts of your application. Really common for routing of traffic between microservices and fully serverless environment, or for mobile applications as well. Step functions express workflows. Step function, in the way that Lambdas are cloud functions with a bunch of other stuff, they have the ability to be triggered by a given event or invoked directly. Step functions are essentially a class of features for Lambda that enable you to run these Lambdas concurrently and do so in a more like packaged environment, so that each of the Lambdas is not essentially packaged and managed and maintained in a fully isolated sort of form where you have all these very, very loosely connected microservices. There are some scenarios where you want sequential sort of steps to happen, or you may want to scale each of those steps independently. So step functions express workflows as a way to more easily orchestrate these services to extremely high concurrency, so or up to 100,000 events per second. And again, these are designed for shorter workloads, right? So around 5 minutes or less. Like if you're running really long-running tasks, step functions are not a good choice for that. You're probably looking at something like AWS Batch. Like if you have a single very large data set to crunch on, AWS Batch or Glue, for example, would be something you'd want to use there. Amazon EventBridge Schema Registry. So EventBridge was something I was talking about to some folks before. EventBridge is essentially a fully managed, fully featured event bus that helps you to manage sort of the everything from service discovery, but also events and the flow of traffic within your given architecture, with you having more control over that. And so Schema Registry is really important for that because it now enables you to structure schema and more metadata about these events, be able to conditionally write applications that can behave differently based on the schemas that you've registered at different points of this. So we have 15 existing SaaS partners whose schemas are there available at launch or in the preview that was launched at reInvent. And this is available for, it has bindings for Java, Python, and TypeScript. Okay, next up, Amplify for iOS and Android. Amplify is a developer toolchain whose goal is to make using AWS services or performing certain workloads as streamlined as possible. It's really, really powerful, and in just a few essential commands and wizards in the terminal, you can completely deploy static websites, web apps, and now with Amplify for iOS and Android, mobile apps as well. So Amplify is entirely open source. The backends for this is obviously going to be AWS features, but I know developers that work and modify Amplify sometimes to work for their existing custom architectures. But for Amplify for iOS and Android, again, it's going to be a streamlined developer experience for adding parts of your apps that everyone is going to want to have, things like authentication, analytics, AIML, databases, and so on. Libraries and SDKs for native iOS and Android. Amplify Datastore is also a really, really, really exciting augment to the Amplify family. So when you have a mobile app, you may want some sort of, or any sort of like a client-side app. You have some sort of data store on the cloud. Typically, you have to write code that directly interfaces the two together. And so now you have to figure out that in the language of your client, either Android or iOS or JavaScript, that has to interface directly with bindings or APIs or SDKs for whatever database or data store you have. Now this permutation sort of set explodes when you think about having a bunch of different clients, a bunch of different data stores on the back end. What Amplify Datastore as a service is, it is actually a managed GraphQL layer in the middle, GraphQL, graphical query language, where the client makes queries on entity types, but it doesn't have to know how they're resolved under the hood. So the GraphQL server is essentially like a proxy that doesn't just offer all of the things like I mentioned for like RDS proxy, for example, but it actually can go and resolve requests from a DynamoDB database or like an S3 bucket or wherever your data is. And the benefit of this is that you write your GraphQL via AppSync, and then with Datastore, you can more easily integrate this using Amplify. So you say you have your application, you say, use Amplify Datastore, it's going to provision an AppSync layer, and then all you have to do is point your application at the AppSync layer, and in the AppSync layer, you just pair those different tags to different data sources, be it S3, DynamoDB, Aurora, what have you. Okay, extending AWS. IoT is something that's extremely valuable for a lot of different reasons. This slide isn't anything on launches, and I want to make sure we're not going too over on time, so I'll sort of skip through this. But on November 25th, end of November, right before reInvent, at IoT Day, we launched a handful of different services for IoT and our various offerings here. First up, we have AWS IoT Greengrass. This is going to be sort of like fleet not necessarily fleet management directly, but distribution of software to IoT edge devices. So things like Stream Manager for handling your data streams amongst IoT devices, and container support to be able to more easily package and deploy workloads to these given IoT devices. AWS IoT Core is the fundamental SDK that developers leveraging IoT devices need to use to be able to interface with the AWS side or with the cloud. Directly, and so we have a lot of features there from fleet provisioning, configurable endpoints, basically a lot of quality of life additions, even in Alexa voice service integration, so that you can be using Alexa voice input and have that resolved to an Alexa application or server on the cloud, even if you're not talking directly to an Alexa device. IoT device management, secure tunneling, and for IoT site-wise, we have another monitoring tool released for that. Okay, so I just mentioned AVS, Alexa Voice Service Integration for IoT Core. This was announced a week before reInvent, and essentially you can build using built-in like the Alexa service, essentially, which is built on top of Lex and lots of other core and fundamental foundational AWS services. For IoT Core, you can start to use any sort of audio input as a tie-in to an Alexa resolver on the cloud. And you can use that to create your own IoT devices and essentially without having to attach an Alexa to them or recreate your own version of Alexa with all of the foundational primers, you can go to market faster with built-in applications that are already on the Alexa marketplace. Container support for IoT Greengrass. We all know why containers are really valuable. They make you able to run software anywhere. And so with IoT devices, this is a little bit more complicated with the various types of architecture, limited compute and memory constraints, some funkiness around some of the operating systems. But with container support for Greengrass, this makes it even easier to build once and deploy anywhere. Next up, we have AWS Outposts. These are now generally available. So this is actually really, really, really exciting. We announced this, I believe, last year, but it's now generally available. An Outpost is essentially a AWS private cloud that's running on a physical tower rack with fully self-encapsulated cooling. All you have to do is plug it into a wall, backup energy, all of that, and all of the software, well, the supported software that we run on AWS, if there is an extreme need to be able to run this in your own data center, but you still want all of the value and the efficiency of AWS services, and it being essentially a managed service that's is still managed from the cloud, you don't have to open up a terminal that's hard-lined into it. That's where Outposts may come into play there. There are scenarios where hyper low latency may be important for you, or extreme data security to an even further extreme than some of the certifications that AWS services have. It all comes with a single pane of management, so even though it's a physical device, it can exist like another entity on your cloud infrastructure. That's not generally available. That's what this looks like. We have some of these on the floor at reInvent. It's a real hulking beast of a thing. If anyone has spent time around data centers, it may look pretty familiar. And I know that a lot of people, when thinking about cloud, think this is a complete journey away from on-premises. But there are scenarios for some customers where having the physical computation or storage of data for, again, security or hyper low latency are necessary. And so that's why we came out with Outposts. All of these services that you know and love, EC2, ECS, EKS, EBS, S3, these all run clients and servers essentially on this actual physical hardware. And these are very similar to the hardware, or nearly identical in some cases, depending, as some of the infrastructure that we run in our own data centers. But again, this is designed to be a product for a customer, and so there's differences around that. But as far as performance and anything that you buy from the hardware perspective, all of the benchmarking will behave the same on an Outpost as it should on AWS infrastructure. Okay, next up, services that are supported locally on those Outposts: ECS, AKS, AppMesh, EMR, RDS, S3. Again, we're thinking the basic compute services or compute services need big data operations, storage of data, databases, and S3 is coming in 2020. Okay, local zones. From a compute perspective, this is something that's really exciting. If an Outpost is a little extreme to have a physical device, which in many cases it will be. A further extension or a point of presence has been popular in the past for content delivery on like a CDN. But when it comes to compute, local zones are another step closer from the nearest data center or the nearest availability zone to be able to get compute happening closer to your user for these low latency scenarios. Again, the sort of value proposition is self-describing in a way. By putting these local zones even closer to you for these time-sensitive workloads, they can run even quicker. They are available in GA on December 3rd. These local zones will be released over time throughout the network and throughout the different regions. The first local zone we're going to have is going to be in Los Angeles, for example. This enables us to more quickly roll out these hyper-local compute POPs, points of presence, without needing to completely introduce another region entirely, which may not always make sense when existing AZ infrastructure and region infrastructure is as resilient as it is by design. AWS Wavelength, very interesting. This was co-launched or co-announced on stage with I believe the CEO of Verizon. This enables you to embed AWS compute and storage inside telecom providers' 5G networks. So this is essentially a synergistic relationship between telecom networks and AWS backbone to be able to more easily and more effectively route traffic, but also to again get some of the storage, get some of these services running in these local zones closer to you from database, storage, compute, and so on. It plays very closely with the local zones, as I mentioned before. Providers that we have already announced partnerships with include Verizon, Vodafone, KDDI, and SK Telecom. Okay, AI and machine learning. So at AWS, we have what we call the AWS machine learning stack. It has 3 tiers. How many people are doing machine learning here? I'll try to keep the explanation. Who's interested in hearing extensively about AI? I don't want to bore you if it's not something. All right, I'll try and go pretty quickly. So 3 stacks. They're ordered in level of abstraction. Here at the bottom, you have the most foundational services, so like the frameworks. Think EC2 instances, Think an EC2 instance with a GPU attached to it to perform training, like our P-class instances. And then as you get up here, we have SageMaker, which is an orchestration layer on a lot of that, so you can easily perform training without having to manage these complex GPU clusters or messing around with NVIDIA Docker. And then here at the top, we have the highest level of abstraction, which is where we found specific repeated business problems that customers face, where we can build a model or a managed service to solve that problem. These are really, really exciting, and we have a lot of them now, especially come this past reInvent. I'm going really quickly. Rekognition does computer vision and video detection. Amazon Poly vocalizes text to speech, so you can automate vocalization of blog posts. Transcribe takes audio and makes it text. Comprehend takes text and gives you sentiment analysis on it, like the example I gave before with the Aurora ML integration. Translate does exactly as it says, text-to-text translation. Textract, you can scan a picture of a document that has nothing but pixel data, so no actual numeric data about the image, and it will actually semantically extract structured data. So you can actually get what is essentially a X by Y array of data from a scanned spreadsheet and immediately operationalize that data. Extremely valuable, and physical documents exist in every single industry to this day, and being able to skip the manual typing process and move to automating that is immensely valuable. Amazon Kendra is actually extremely intelligent search built off of the same technology we use internally for our specific search engines. So if you have multiple different knowledge repositories at your organization, or resources or PDFs, guides that you want to search, Kendra is essentially a managed service that helps you plug into each of these different data sources, and there's a lot of really neat features around it that'll help you improve it over time. Let me just make sure that I don't have these as slides so that I'm not duplicating myself. Sorry. I may have some of these. We'll just go in. AI services, so we call pre-invent, or people on Twitter coined it pre-invent. These are all launches that we actually launched leading up to reInvent. Amazon Comprehend can now understand sentiment in 6 new languages. Translate now supports 22 new languages. Transcribe can now go audio to text in 15 new ones, as well as having alternative transcriptions based on the confidence. Transcribe, as with all of these, will actually give you confidence values for every single word or term that you're using. So you can conditionally program applications that do different things when it's not confident or when it's very confident, and you set those thresholds. Lex is a managed chatbot service. There's a lot of compliance and analysis and integrations built into that are new. Amazon Personalize, essentially feed in your historical data for your user history, clicks, or so on, and you can, in essentially an auto machine learning fashion, have Amazon Personalize create a recommendation engine where you feed in those users, and based on their historical data, will recommend a new set of content based on the labels for them. Again, powered by supervised learning. You need those labels and that historical data for that to work. And then Amazon Forecast does a similar value proposition, but instead of for personalizations or recommendations for content or products, does that for numerical forecasting. So think about like amount of energy you've utilized or amount of sales you've had, and you have a bunch of features that feed into that data set. Forecast can try and predict in for the future what those values will be, and you can use custom quantiles for those predictions. And region expansion for a lot of those services. Okay, Transcribe Medical, really valuable. It's valuable when we can understand sentiment, when we can transcribe audio to text, but we find that in a lot of scenarios where you have things like acronyms and medical terminology, or just specific nuanced terminology, that this breaks down or it just gets you essentially gibberish. Amazon Transcribe Medical is a specific delineation of the transcribe service that is intended to be accurate for US English, and for the majority of primary care scenarios, because they're a very large customer base of ours, and we heard that this is a resounding pain point for how much time it takes to process all of this audio data, or that it completely goes missing and then patients don't receive the care that they should. So Amazon Transcribe Medical, again, purpose-built solution for transcribing with that particular lexicon. It's extremely affordable, and it's an API. You just pass in your audio, you get back the text with the confidence values. Developers use APIs all the time, so we understand how to use this to make this operational really quickly. This is a demo of it working. I don't know if I have audio. Do we have a sound for this? It's going to be really quiet because it's a TV speaker, I think. But
Rob back there. Can you grab the remote?
Yep. While he's grabbing that, I'll go forward, and we'll go back to it. Next up, we have recognition custom labels. So you may want to crank it to like 50 or 40. All right, I'm playing it now.
The liver attachments to the adrenal kidney were divided and the liver was reflected superiorly. The vena cava was identified.
So what you're seeing here is this is real-time transcription. This is not batch transcription. Transcribe supports both, but the much harder problem is real-time. And so you're seeing in real-time as the person is saying there's obviously a small bit of latency while it's processing, but we see the original script the person is saying there on the right, as well as the different sentences here. Transcribe also has built-in sentence separation, so this is why you see it returning on a new line for each pause that the user makes after each sentence. Transcribe recognizes that automatically. So this is just one persistent open connection feed to the transcribe service, and these are the results that it gives. Again, lots of otherwise really tricky and esoteric words in the medical space, but the service performs extremely well. Okay, next up, recognition custom labels. Recognition, a service that enables you to do computer vision as an API, essentially. We've trained models, we continue to improve them, you pass an image, and you can find out the objects that are in there with the confidence values associated with them. If you have image data in any way, understanding a little bit more about them is typically very valuable. There's lots of other things you can do, like understanding the sentiment or the feelings of the faces that are within it, the bounding boxes for people inside of them, and so on. This is really common in like customers that have to like manage a facility or a workspace where people should be in certain areas at certain times, like in factories, where they want to detect that they have like a helmet on. Now, one thing we found is that customers can train their own models from scratch and learn a lot about machine learning with SageMaker, or they can use our pre-built model with recognition, but there's this area in between where they may have a label that's really specific to their business, like, I don't know, like maybe there's like very specific types of phones that we may not have in our data set, and they want to build a custom model for those. Typically they have to build a model from the ground up. Now you can actually supply basically a folder of these images and hit train and in the console with a button, and recognition will now add and append your custom label into the data set. So you get the fully managed aspect. You don't have to know any machine learning, and if that general model is really good and you just want to add a few labels, you can do that now very easily with custom labels. Now, when it comes to labeling data, I mentioned before supervised learning. You have historical data. This is all of the features, but then also the outcome for it. So if I had a bunch of pictures of phones, I'd need the pictures, which are the raw data, but I'd also need the label that this is an iPhone 7 or this is a Samsung Galaxy whatever. Those labels are essentially how the machine learning algorithm knows to differentiate between the different classes. And so this is otherwise a very laborious and manual process to create this labeled data. But with something called Amazon Recognition or Amazon SageMaker Ground Truth, they can automate this process by distributing this workload to a large number of people. But what we found is that there are scenarios in which once these algorithms are put into production, there may be things like model drift, or there may be scenarios where the live data that's coming in is different than the training data that we've had. So we want to have scenarios where we can pass in some of that new data to be part of the training and have humans involved in that loop. They don't ever get completely abstracted away. So we have something called Amazon Augmented AI, A2I. Essentially, you can have thresholding-based confidence for when images are either automatically labeled, either in an inference or in a training scenario to go into into your new model, but also to threshold and have that sent to a human reviewer as you decide. This type of workflow was seen before, and we recommended customers to build this on top of Ground Truth, but now we've launched that as a fully managed service as well. Because every customer that used Ground Truth essentially wanted to build that pipeline as well. So we just did the customer-obsessed thing and built it for everyone. So this is exactly what I just described. You have applications, they feed training data into a machine learning algorithm, and then at a certain point the machine learning algorithm can actually start to predict the new labels for the other training set in addition to inferring on new images. But what we really want to do is we want to have this intelligent system where when it's really confident, we don't need to send that to a human and it can automatically be labeled, but if it's not confident, we want to automatically route that to a human so that they can give a double check on that. That's how A2I works, and you can set the thresholds for what very confident means. all of these predictions come in on a scale of 0 to 100, and you can set whatever those thresholds will be for your company. There are various different human workforces. There weren't too many people that were interested in AI, so I'll try to breeze through this really quickly because we're coming up on 8 o'clock and I want to make sure we have time for questions. So this is what it looks like to be able to have one of the GUIs for labeling. You're given images. This is a multi-class classification. Maybe you have a data set of sports. Here we see a picture of soccer. And you ask, basically the GUI asks the labeler to say which of these labels is this: soccer, swimming, football, basketball. We see that this extends not just to images but also to textual data as well. You can highlight you can have it automatically highlight the text and then have the labeler need to specify what the specific text was there. Okay, next up we have fraud detection. Fraud detection is very difficult. It's a very particular subset of anomaly detection broadly. Bad actors, whether it be people trying to set up Bitcoin infrastructure and mine it on your architecture, or stealing your credit card information just as a regular consumer, it's a big problem and it's difficult to detect fraud, especially with people that are very good with it. Fraud detection with ML it helps, but it's not perfect, and it still requires a lot of specific data augmenting skills and data science knowledge to be able to do it right and effectively. So what we've done after our extensive history at AWS, or at Amazon, actually even on the retail side, of having to predict customer fraud and purchase fraud, both on the account sign-in side but also on the purchasing side, we've now launched a managed service called Amazon Fraud Detector that enables you to more easily integrate fraud detection into your business at real time. So when people file a transaction, you can have that transaction fed into Fraud Detector, and then whether it detects if it's fraud or not, you can then either choose to continue the processing of that payment or decline it based on the results of this. So what this looks like is you can have a large number of events here. These are going to be either purchases or account sign-ins. And so Fraud Detector will automatically, based on the pool of events that you have fed into it, be able to train a model to understand what is likely and not likely to be fraudulent. Think of this like when you go to another country and you booked the plane ticket on one credit card, but you swipe the other credit card. There was no event that the other credit card company would know that you were in the other country. So based on those events, it would trigger that was fraudulent, right? This is the same idea here, but then based on user profiles that are unique to each user, whether this is purchases or sign-ins, and various different features that you can have, either verify as real or have it be labeled as fraud. You can choose how to escalate this as necessary. You can add specific rules if you want to add very particular nuance. Typically, the best approach is a semi-automated approach, as we see on the left, by passing in historical data, but then also defining some hard rules. You likely understand your customers and their journeys, so there are either scenarios where you know it will definitely be fraud. You can sort of hard code those in the policy on the right, or scenarios that you know are very common, but like the one I just described, and you have a way of being able to reflect that in the data. You can also add that in there under the rules to help prevent false positives from, dinging your customers all the time. The process of using this: put your training data in S3. Now, Fraud Detector handles all of this in the middle. Once you have gone through the console, you just cite the S3 bucket, does data validation, enrichment, feature engineering, all the hard, low-level data science and machine learning expertise stuff. And at the end of everything, it deploys the model and hosts it, and you have a fraud detector endpoint with a unique ID that is completely auto-managed, auto-scaled, fully managed, so that when your purchases go up, you don't have to say, oh, I have to go turn up my fraud detection architecture. No, it's all fully managed. You just pay per request. Contact Lens for Amazon Connect. Connect is essentially a contact center in a box. Everything you want to do, from being able to have people that are answering the calls, to routing the calls, to understanding and logging all of the data. Now Contact Lens is giving you direct insight into all of the parts of that application process, figuring out anomalies amongst your different the calls, sentiment analysis, and all of this. Again, more of the common workflows we've seen customers take from the other services like Comprehend to understand the text and bring it all together into the suite of Connect, because this is where customers are using it, and there's no reason we shouldn't have built something like this. It's currently in preview, and we're going to, I would imagine we're going to be adding more and more functionality and insight into this as time goes on. Examples of this are as follows. So you want to be able to visualize recording and transcript and back and forth. So you have two people on a line. You may want to see person A or person B. You can actually visualize that over time here by these different colors. You can visualize gaps or time that people are on hold. You can visualize the sentiment. How is the conversation going, essentially? Is the person happy? Were they upset? And then they left the call upset, and then hopefully happy. You know, these are all things people want to use, and they were building it out on their own. So we figured, why not help everyone out? Because this is something that we want our customers to focus on their businesses, not necessarily writing dashboards all the time. This is further introspection into a given call, which would be a contact trace, and you can see over the course of the call you have some sparkline sort of metrics there that are at a glance very easy to sort of make use of. Next up, Code Guru. This one's really exciting. Essentially, it is code review as a managed service. At AWS, we have lots and lots and lots and lots of historical data of all of the code reviews and performance analytics on different the segments of code and applications that we've deployed. Code Guru is an intelligent code reviewer. You pay per line of code, or it's a price per 100 lines of code, what have you. But essentially, Code Guru does two things. One, it does a static profiler where it can predict or essentially surface suboptimal decisions you've made, sort of as like a static linter on steroids. So we can say like, oh hey, like you're using this outdated version of this library, and because you imported it, it then knows the most up-to-date documentation from that given library or that that index, and it will actually warn you of that. That's something your default linter or your default interpreter may not tell you, but Code Guru will, and that's just one example of very many things. Additionally, if there are inherent suboptimal things that you have done, like if you have a sort of nested loop scenario that is objectively inefficient based on how you're iterating across it or the actions you're taking, Code Guru can actually tell you that you the specific alternative that you should leverage to the way you program something. So it's like, I describe it as having like a senior principal engineer right behind your shoulder that will tell you all the things, not just that you're doing wrong, but how you can do them better and make them more performant for your application. This describes everything that I just said. It uses machine learning. We have a lot of historical data from our own code reviews on the Amazon retail side in AWS, and we're now bringing that to developers everywhere through the form of a managed service. And it's outputting, again, recommendations. It's not necessarily like, it doesn't just automatically change your code for you. You could program a workflow where it would do that. But the idea is for you to understand why it was wrong so that you can also be better. I don't imagine a world where everyone has all their code reviewed by Code Guru. The idea is running Code Guru periodically on your code can help make your developers better and power them up so that they don't make the same mistakes repeatedly. And you don't need someone else to have already known that at your organization to make them improve. Code Guru can help you with that. The scenario I described before, looping versus waiting, or iterations across nested for loops and such. You see an example here which will be inefficient, so the recommendation is actually pretty nuanced. It says this code is waiting before the resource before it runs. Use the waiters feature to improve the efficiency. Consider using table exists, table not exists, so on, with a direct link to the documentation. And so developer feedback, what you should get from that is like, hey, we should use waiters instead, and that'll help remove a lot of the code, make it more readable and probably more performant. So there's the passive aspect, which is like the static linter or the static analyzer, like I just mentioned. You pass in your entire repo, but then you have the active portion of it. So imagine if you could just run your code through like a multimeter on your workload and have it tell you like, oh, like this part of your application is waiting for this part of your application, or this is like this object is kept in memory for no reason for a very long period of time, and then it makes it inefficient and scales out unnecessarily. That's actually how Code Guru Profiler works. You take a dynamic workload or a workload, and you can actually push it into Code Guru, and it will profile it and perform a flame graph of what that looks like over time to sort of see the collapsed stack traces amongst one another. Let me see if I can get a picture of that. This is an example of recommendations again with a code fix. So this is what we see in the bottom right hand here. So this is an example of a PR. And this is the problematic line of code or the block of code. And then over on the right-hand side, this is the report that Code Guru's active profiler returns to you. It's going to give you the who, what, when, where, why. Well, not the who, but the PR that it lives in. And here at the bottom, it actually gives you the collapsed stack traces of all of the different functions and methods of your workload that are running. And so you can actually see visually which parts of your application and which callbacks are either sitting latent, taking up memory or threads, and hopefully that lines up, or it should line up with the recommendations as listed above. Flame graphs are a really cool concept for observability and introspection that came out of Netflix open source, and they've released some open source libraries for performing these visualizations, and that is actually part of what powers some of this. Netflix, huge on open source, and they're actually one of the customers that's all in on AWS. They don't manage any of their own infrastructure. Cool. So, all right, these are just some top-level numbers for why. Oh, actually, no, sorry. This is going into Kendra now. So I mentioned that before. High-powered search. People spend time looking up things. We know this. I don't need to give you the stats. So we launched something called Amazon Kendra. At AWS, we have so much data across so many sources. We have internal wikis, we have documents, we have PDFs. It lives in so many different forms, even databases, for example. And we want to be able to have one search bar to query everything. And so we've made improvements to these products internally and what we use, and so now we're trying to surface it for you as well. So we have a managed service that enables natural language queries, so you don't have to search these exact words or phrases that we think about constructing to optimize for the results. Again, like we start with human language and we can deconstruct the queries and run parallel queries on multiple iterations of this to return what would be essentially like the union or the intelligent, most likely outcome that you are wanting. This uses natural language understanding, obviously, to be able to extract that, similar to technology we use in things like Alexa. And the idea is, at the end of the day, it is a very simple API that you can point your data sources at, and it will continuously improve over time as people can thumb up and thumb down results. So use reinforcement learning to actually adjust on the fly as you're using it the results that it will be giving your organization over time. So it can truly be customized for your use case. So make it really easy to find what you're looking for on the user side, but also it has to be really easy for you to be able to set up at your organization, otherwise it's just a pipe dream. So we really like to be able to deliver on both of those. These are the connectors that we have working for it. So these are, again, being all of the data sources. So no longer do you have to go into like your Exchange search bar and look through your emails there, but then go to somewhere else, look for something else, Box for files. No, you can actually put these all in as connectors to Kendra and search all in one place, and actually have native hot links out to the locations of each of those, or at the very minimum pointers and like plain text copies for emails or something. So very extensive, and these are all of the ones that are going to be there for launch, with more coming in 2020. So this is an example of what it looks like. Here's the search bar at the top. Someone types, when is reInvent? And so we actually have a handful of very intelligent surfacing in addition to pure links with description. So here at the top, if Kendra is actually really confident in an answer to something that is a natural question, for example, it's not necessarily you searching for specific data, but it has to resolve that as a question, it will actually give you the excerpt and the direct answer there with the source as well. Thumbs up and thumbs down for that. That feeds back into the reinforcement learning. Here as well, if this was from an FAQ, for example, on a given page, we have these really easy to use drop downs that have a bunch of other related questions with the answers there as well. These are things we see in other search engines. It's a really good user experience, but you have full customization over all of these things, and they're available out of the box. Okay, ML services. I know there's not too many people here interested in this. We'll fly through it. SageMaker, again, the orchestration layer for a lot of the underlying services. Has some tie-ins for the dashboards in QuickSight, has some tie-ins to Aurora now with ML, and you can deploy many models on one SageMaker endpoint. This was stressful for customers before because they would otherwise have to deploy one model on each instance, which obviously is not ideal. SageMaker operators for Kubernetes. Hey, you love SageMaker, you like building machine learning models. Hey, you like Kubernetes. Now they play really nicely together. SageMaker Studio is really cool. Everyone who writes code knows how important it is to have your IDE set up in a way that's comfortable for you and is really performant. In the machine learning space, there hasn't really been an IDE that's been the be-all, end-all yet. There's a lot of inefficiencies, even though there are lots of really great tools out there like Jupyter and interactive notebooks, Jupyter Hub, Jupyter Lab, for example. And so we launched SageMaker Studio to basically build a IDE that more closely ties into all the cloud services you want to leverage for machine learning on the AWS stack. So you can imagine a lot of stuff around that, everything from just better introspection into training jobs and deployments, but also better insights into how better like code completion tools that aren't directly available in things like Jupyter Notebooks. This is an example of what this looks like visually. Again, if you don't work with machine learning all the time, it may not seem too impressive, but essentially it has everything that a developer is going to want. It has your code, your cells here on the left-hand side. It may have a current running job that's piped on SageMaker that's piping the data right back into your notebook, so you can see this all in one tab. You don't have to have 5 different tabs open and jump between them. And then here on the right-hand side, you can have jobs that you may have run on SageMaker, which would not live on a CloudWatch metrics page, but may live on like the SageMaker experiments page. So these are things that all live in different places. People want them all in one place. SageMaker Studio finally enables you to have that. SageMaker notebooks. These have existed for a while. These are, again, hosted Jupyter. They're really valuable if you're trying to do data analytics or try to prototype, live coding is really fun on them. That's what I use them a lot for. But again, interactive sort of programming environments, typically for Python. These are now more easily shareable and can start even quicker. You can share snapshots of notebooks. I think that's actually the specific launch here at reInvent. So rather than having to share the entire file of the Python notebook, you can just share a snapshot directly through your AWS account instead of having to like transfer the file offline to someone. We have SageMaker processing, analytics jobs that are closer tied into SageMaker so that you don't have to use direct interfaces or bindings for tools like Glue or Redshift. Sorry, I'm getting through it. There's a lot of AI and ML launches. SageMaker experiments is essentially the logging and introspection that you want for all these experiments without having to write plotting code and setting up a bunch of custom CloudWatch metrics that people may have had to use prior. This is an example of this. So this would be, like we have one tab at the top. This is your SageMaker IDE, and you may have a list of components on one side. You may have this chart. This is code that developers would have to write on their own and would be really difficult to manage. And then you want to write your Python code, but then you need to write AWS code on top of that to pull the metrics in, all in one place, all out of the box, with native filters and sort all built in already. These are all, again, standard metrics everyone would want to see. Debugger, explainability, alert generation, observability into how machine learning models are performing, really valuable. Again, otherwise things that people had to write a lot of custom code to do on their own. If you're not really working a ton in machine learning, I know this may not be super exciting, so I won't drag on it too long. Examples of this are as follows. Issues with your code. Vanishing gradient is a very common problem that you want to be able to know as quickly as possible to alter your code and rerun your experiment if possible. Otherwise, people have to define that on their own. Continuous monitoring for applications. This is a clear value add, and now we have this for your models that are deployed as endpoints. Again, think of these as fully managed microservices or HTTPS endpoints that are powered by all the machine learning work that was happening in the training. We have more graphs around this, but we can also see the current service status, but also the utilization for the model as well as the prediction. So if it's like a dog versus cat predictor, it'll give you in real time the breakdown of the distribution between the two as well as the confidence values. SageMaker Autopilot, this one's really exciting. So if you've never done anything machine learning before, but like a off-the-shelf API is not going to work for your use case, Autopilot may be really, really valuable. Basically what this is you've probably heard of AutoML. This is our managed service for AutoML. You take your data, you point it at SageMaker, you say, hey, SageMaker Autopilot, I don't know what algorithm to use. I just know that these are the features and these are the amount that each of my customers spent. Can you please try and build a model for me around this? And SageMaker Autopilot will. But you still get full visibility and custom control where necessary, but the idea is that it's as much of an automated experience as possible. You see these just run as automated jobs after you pointed them to the respective S3 buckets for the data source. If anyone is interested in Deep Racer, we actually had some really cool improvements. So the Deep Racer Evo is sort of like the Deep Racer 2.0. Deep Racer is, again, like a RC car that you can control from a tablet or from a phone. There is a simulator to train it using reinforcement learning in the console, and you can actually transfer that onto the RC car and have it learn how to self-drive. That used a camera, and it read pixels from the road to try and determine where the lines and where the road may be, and that's what the model tries to predict. We actually took it a step further, and we realized a lot of customers wanted to work with similar hardware that is used on autonomous vehicles out in the wild, like LiDAR. Deep Racer Evo is actually now a car that is equipped with both a regular optical camera, but also a LiDAR sensor. Additionally, it has a stereo camera to actually be able to assess depth. which is something that's not available in a standard, RGB image. So all of these things together really enable you to, if you want to start working on simulating and training models and seeing what that looks like for autonomous vehicles, but also putting them onto a real car and racing them. We have a circuit all year round at the different summits. This could be really exciting. We have a lot of improvements to the virtual leagues where you can create your own races and tracks and all of that, and custom scenarios where you have obstacles on the course. It's really exploding. People really love it. And if you're at any of the summits, or you can make it to the summits, I would definitely recommend trying this out, even if you're not machine learning oriented. This is one of the ways that we love getting developers hands-on with machine learning and actually seeing it firsthand. This is probably a video. I'll just. This is I think this was the announcement video for the Deep Racer Evo. So you can see the stereo camera, you can see the LiDAR camera. This is what it looks like with the shell off. And we had our international championship at reInvent this past year, where winners of the regional summits actually won spots at the tournament at reInvent. And we have videos that follow the journey of the circuit all year round that are pretty fun. And that was the announcement there at the stage at reInvent. I have 8 slides left out of 120, so I know I'm 10 minutes over 8 o'clock, but I promise we're getting through this. AWS Deep Composer, Generative Adversarial Networks, GANs is what they're called. They're a really cutting-edge form of AI neural network architecture where you have 2 neural networks that kind of compete against one another. They're really commonly found in style transfer or artistic implementations where, let's say, I want to take a picture, but I want to apply the style from a famous painting, for example. That's a really common example, but we're really interested at AWS on the music side, and we know developers are as well. So we launched a tool called AWS Deep Composer. It's a standard MIDI keyboard that basically, when you play music into it, it will use GANs under the hood to then generate a drum line, a bass track, and other accompaniment to you playing the piano. So really cool stuff. Again, enabling you to be hands-on and get developers interested in machine learning that may otherwise not have been. You can use a pre-trained model for different genres of music, like rock or rap, R&B, so on, or you can train your own. This is an example video of that from reInvent. I'll just skip through it in the interest of time. Frameworks and infrastructure. EC2 Inferentia, I mentioned this before. This is the computational chip that powers the new EC2 Inf1 class. Again, focused for AWS AI and ML developers. Fast, low latency inference at as low cost as possible. There's a particular SDK for this for Inferentia because it's actually a little bit different architecturally, but the majority of the code stays the same. We're going to have support for TensorFlow and all the common frameworks. But if you're using deep learning AMIs or deep learning containers on AWS already, it's available there today. Deep Graph Library is performing deep learning on graph architectures or graph data models is very difficult, but it's kind of like the next frontier of assessing value out of data that people already have. There's been so much work on tabular data. There's been so much work on computer vision, on images and video, but really understanding and surfacing results from graphs is the next step. So support for Deep Graph Library and the deep learning containers is very valuable there, and we're going to be having more launches for that on SageMaker. Deep Java Library, deep learning with Java bindings and being able to deploy in Java is valuable. Train using your own model or use one of the ones that we have in the existing library. That was a lot of launches. Thank you for bearing with me. My voice is barely hanging on. I know this link here at the bottom is not too great, but I'll try and leave a slide up that has all of it. And I think, without further ado, that was it. That was 120